Okay. Just recap of what we have done so far. So we are learning arrays. Arrays is nothing but a structure for you to store your data, which can be of any type. The motivation for arrays came from the thing that if we have to declare 50 variables, then doing the explicit declaration would take you a lot of time, like define int mark 1, mark 2, mark 3 up till mark 50. But that is a bit tedious process and a bit boring. So to help us in that, what we have is called arrays. Arrays give you a continuous memory allocation, something like this. This is how you declare an array of length 100. Uh, and after that, it's just like a variable. So if you do this, this means the ith element of the particular array. So this is how you would use an array, and this is how we would print the values of an array. So yeah, I guess that's the only thing that we have done so far. Does anyone have any queries in whatever we have done so far? Again, arrays are nothing but a place for you to store your data such that you can use them more effectively. If we had to, okay, any specific reason we use two loops. So yeah, Vinny, that's a nice question, and I hope it's obvious that we can do it by using one loop itself. And we, if you think it that way, we did not need a loop array in the first place. We could have just done it like cout I square. Would have also been done the same thing, but I just wanted you to show how array can be used. An array, I would just write it maybe. This is how you declare an array. This is how you assign values. This is how you print the values. So again, if someone doesn't know, this slash thing is for comment. So slash means the code after this won't be counted in your particular file. It would be completely ignored. That's why you can see it in a lighter tone as well, lighter color as well. It's like a comment to your code, which is exactly what I'm doing right now. So this is the declaring of the array. This is how you assign the value, and this is how you print the value. Okay, yeah. Yeah, for definition and output, yeah. So this is declare, this is assigning the values, and this is printing the values. Again, once you have declared, you can use an array exactly like a variable. Arrays are just for you to store your data more effectively, more beautifully, make your code a bit short, and for you to do things more effectively. Like you would be able to appreciate the importance of arrays only in future. Right now, you can just think it's a way for you to allocate, define a lot of variables together and use a lot of variables together. So that's the importance of arrays. Again, I will remind you, data structure is nothing but a cupboard for you to store your store the data that you have, and how it additionally it also provides you some facilities which is dependent on that particular cupboard itself. So I hope that idea of data structure is clear. And arrays would give you a continuous allocation of variables of any type that you want. In this particular case, we had used integers. So I hope the definition of arrays and the usage of array is clear. Okay, if you have any questions, please feel free to raise your hand. Like since we are just starting up this thing and we can't have questions, so please feel free to ask. If you won't ask the question, that's only your loss. Okay, thanks a lot, Prasad. Can you try unmuting yourself? Yeah.
Hello?
Hello, Prasad. Yeah, I can hear you.
Why you have used the first 100?
Okay, yeah, that's a nice question. I would just address it in some time. Yeah, thank you, Prasad. It's a nice question again. Like you can ask that if you only had to use 50 values, why did you use why did you declare 100 variables? So I will just answer that in some time why I did that. Any other question? Please feel free to ask and unmute. Don't think of, okay, what I would think or what others would think. Yeah, Arvind, that is correct that I declared excess just to be safe. But exactly how much should you declare? Why declare only 100? How would you know exactly how much to declare? Well, that's a nice question. That's a question to be addressed. Akhilesh, do you have a question?
No, I think it should be answered like in a
Okay.
way.
Yeah. Okay. Anyone else who have any questions, please feel free to ask, even if it's a very basic question. You can ask me anything, to be honest. Like you can ask me, okay, what is the line about this? What is for loop or anything? I would try to give you a brief idea if you don't know. So please don't feel embarrassed on anything. Like at least that's one nice point of the online thing, that you don't have to exactly show yourself. So you can write in chat or you can unmute yourself and ask, raise your hand. But feel free to ask your queries. Don't let any queries be with you. That would only make the process of learning difficult for you.
Bro.
Yes, Sudan.
Actually, could you please explain that preprocessor directive? What is the difference between IO stream and that what you are using right now?
If I will just give you a brief idea. So basically, IO stream is input output stream, and what it does is gives you the access to the cout and all the input output related functions. So again, a computer, you can imagine it like a robot, and like a human, maybe I would say, who just have a lot of super computational powers. So what these line does is, these are called libraries, and what this is called a library, and a library is a library for the computer where the computer will go to read books. So anything that you would use in your code, in your program, should be available with the computer in the library. So a computer should know what it is, and for it, it would refer to its library. So these are called libraries of the computer. IOStream is something that would provide you the input output related books. You can books or functions. It will provide you books related to the input output. While this is standard template library, which is like a bigger library, it contains IOStream and a lot of other libraries. So you can say it is like IIT Madras library, which has lots of books and all. So basically, it's like a much bigger library which has a lot of functions and all. So for most of your learning, like most of your time in C++, if you would just use this particular library, you don't have to care about anything else. Is it clear, Sudan?
Yes, bro, I got it.
Okay, thank you, Sudan.
I had one doubt that when you declare mark 100, so 100 variables are declared or 99 variables are declared?
100 variables are declared. I would like go into the details of what it is exactly. That would become clear.
Okay.
Thank you, Arpit. Is there any other question? You can raise your hand, write in chat. It's nice that you guys are speaking up. Okay, Carl, the difference, like there's no difference between while and for loop as such. They do the exact same thing. How you actually use them is a bit different. Okay. Again, for namespace, I won't go into the details. You can just believe, like you just understand that the two lines combined allows you to do everything in this code. Like that's it that you have to know for now. Like it's not required to go into the details. That's what I would just keep it up, skip it up. Is it possible to make your own library? Okay, that's a nice question. I didn't thought of it. You can definitely make your libraries and use them. Like you can definitely make your libraries on your computer and use them, but that won't be something that C++ would use. So if you want your library to be accepted by C++, you would have to contact them. If you just want to use for your code, then yeah, that's pretty simple and that's something you can definitely do. That's a nice question, Satyankar. For if you want your library to be get accepted by C++, you would have to ask them. I don't think I can do it or something. But that's a nice thing. I never thought of it. Okay, any other questions? Okay. Okay, cool. Thank you, everyone. So let's go ahead with arrays now. Okay. Just hold on a second. Yeah, hello guys, I am back. Okay, so let's continue with arrays now and see, okay, what are the other things. So yeah, like this is, okay, let's like right now we had a pretty simple like values given to the arrays. Let's give them some different values. So let me define a small array. Okay, let me define 100 for now. And I would go into the details of how many you can use. Let me give it a simple name. Say A. A is like a common name for an array. So let me give them different values. So say I give it A of 1 as 2, A of 2 as 5, A of 3 as 7, A of 4 as 6, A of 4 as 9. Okay.
Said that what does A do? Actually, the connection was cut for a
Okay,
second.
A is just the name of the array.
Okay, so means we can define A, B, C, D, and means how many
You
arrays
can
we
give
want.
any name to an array or a variable. Naming is up to you. I gave Mark as the name previously. To make it simpler, I gave it the name A. Is it clear?
Yeah.
Okay, thank you, Arpit. So A is just the name of the array. Like since it was Mark earlier, I guess that would have been more clear to you. But yeah, I guess for familiarity, we are just like for getting like written the code easily, I'm just using A. So we would use ARR for now. And A of 5 as say 9. With me till here. I will just print up the values of the array. Anyone who would like to speak up what the output would be for this code? This is the array. This is the values I have given to the arrays, and this is I'm printing the values from 1 to 5. You can just raise your hand. What would be the output for this code? Okay, we have one raised hand. Let me give some time for others to think. Okay, I think this should be a simple thing. I will just show up my screen. Okay, I will just change this thing, otherwise it would give compilation error. So I have declared an array, given it some values, and outputted the values. Again, initially it might be a bit confusing. Just bear with me for some time and it would become much more familiar to you over time. Initially, again, I do accept that it would be a bit confusing and you won't get it that easily. As and on, when we use it more and more, it will become much more clear to you. Okay, we have much more hand raises now. I just wanted a new person, so I would ask the first person. Okay, Yash Gawande. Can you speak up?
Hello?
Yeah, Yash, I can hear you. So what do you think would be the output for this code?
The output will be 25679.
25679.
Each will be printed on a new line.
Yeah, that would be true. It would be printed on new line. But what would be the output? 25679.
Yes. And our next line will also be printed after 9.
Yeah, okay, that is correct. But your output, I'm a bit suspicious it would be correct or not. You can see it again. 25679 is what you are saying.
It will be 25769.
Okay. Now I get, okay, you got it. Okay, let's see now if it's 25679 or 25769. Okay, we'll just make it a bit big. So yeah, the output is indeed 25769, which is because 1, 2, then this is 3, 7, then 6, then 9. Okay. Yeah, thank you, Yash. I hope you got what you missed initially. So yeah, this is the correct thing. I just made it to confuse you guys a bit. This will be the correct thing. So 25769. And the array is 1, 2, 3, 4, 5. So this would print the values in the form array 1, array 2, array 3, array 4, array 5. That's it. How the values would be printed. Do you guys have any questions or something? You can write in chat or raise your hand. Okay, Raghav was also correct. Okay, yeah. Okay, so let's go ahead. Like again, I guess that is pretty obvious. That should be pretty obvious. Like suppose I change array 2 to be 5, to be say 99, and I print the values now. Say I change some other values as well. I change array 5 to 100, and now let's print the values of the arrays again. Now it would print the, okay, yeah, like these are the old values, 25769 are the old values, 2997600 are the new values. So again, just to remind you, these are like exactly like variables, and just like you can change the variables, play with them and all that, you can do all the things with them as well. So these are like array, like variables. So since you can change variables and give them new values and all that, like you can do all the arithmetic with the variables and do that with the array as well. Again, array is just a way to store the variables. That's it. Any data structure is just a way to store the variables. The core idea remains the same, that they are variables, data, integers, which you can store, play, and do all that. Okay, let's go ahead. Okay, this was the original array. Suppose you changed a of 1 to 7, this value got changed. You might ask, okay, why the first value is not getting changed, which I would show you in some time. Okay, this is the declaration of the array. This is the data type, which was int for us. You can define the array name here, and this is where you define the size. So I would yeah, show you guys what the size actually means. Array with the name ARR. Suppose I give it a size of 5. So as you can see, the declaration of array is data type, which is the type of data you want to store, array name, which is ARR here, or say mark, which is the name of the array, and this is the size, which defines the size of the array. So 5 is the size of the array. Size means the number of variables that you would get by that declaration. So 5 would give us 5 variables or 5 integers stored continuously in the form of an array. I hope that part is clear. And yeah, so this is like, say, float is another type of data type. You may know it or you may not know it. It's completely fine. Char is another type of data type. Mark is a name, symbol is a name, and this are their sizes. You can do the size, like you can give the size in form of variable as well. So I can define int n equals to 5 and give the size as n. So n means the value of n, which is 5. So, that I guess would be pretty obvious. And that's it. So let me tell you how the size is exactly influenced. So suppose you give the array a size 5, then what are the variables that you can access? So ideally what we would think is, if we give the size 5, then we should be able to access, like we should be like the variables that we will get could be mark 1, mark 2, mark 3, mark 4. Ideally, we would think that these are the variables that we can use and these are the variables that we get. So since we had defined the name as mark and we had to get 5 variables, it would be this. Some of you might also ask, why can't it be something like, say, mark 100 and then mark 101, mark 102, mark 103, mark 104, and something like that. Like, where do you exactly start that indexing from? Which is the first index? So ideally, we would want the indexing to be from 1, 2, 3, 4, 5. These are the values that we get. But for a particular reason, which you would like see later on, the indexing in computers, in C++ at least, starts from 0. So the first variable that you will get would be mark 0. The first variable you will get, like what does that mean? It means what is the first index that can be addressed, which can be used. If you use something like, suppose you declare the array mark of size 100 and then you use say mark 100, or you use mark -1, then these are illegal and you cannot use them. It would either give you a compilation error or give you a runtime error. Like this would give you some error in future. I will not go into what exactly that error would be, but it will give you some error. So you can't use that. It's a bit, it is illegal. Yeah. So what you have to remember is, okay,
Can you repeat why mark 100 will be error?
because we have declared an array of only size 5.
But in that previous one only, we first declared array 2 value is something that, and then in the down we declared array 2 is equals to 100 and something that. So why didn't it show compilation error there?
You can give it a value of 100. You can't access the 100th element of the array. So I will give you an idea, like a picture of it. Suppose this was your computer and your computer has a finite memory. Suppose this is the memory it has, right? And suppose you declared a variable of, like you declared an array of size 5. Then what it simply does is, it will take out storage from it, which is of size 5, and it will give you these variables. So these are the 5 variables. It will give this particular location a name, say mark. Okay, I'm sorry for my handwriting. This is, and these are the values you will get. Now mark 100 would be something like here, which you haven't, like which the computer has not allocated you. Arpit.
Yeah, I got this. But I didn't got that, like how there we defined, means on the upper side we defined array 2 is, where means array 2 value is something like that. And on the downside we defined array 2 value is 199. That, why didn't?
So these are variables, right? You can give them any value. You can give it a value of 2. You can give it a value of 5. You can give it a value of 100. You can give it a value of 1 million, something like.
No. But it was variable in the beginning. Then we defined array 2 as 98. Okay, then it got a value, right? So how can we redefine it in the same code only?
Yeah, you can change the value of a variable in the same code. This is what we have done in past as well. Like if you give a variable a value, it is not permanent. You can change it.
Okay.
Okay, I guess this is something you might not be aware of. It's completely fine. So you can change the value of a variable. Yeah. Yeah, after, like even before outputting, if you give the change the value, it's fine. It will just get changed and like not be the same. Like these are some things that you would like you would understand more and more as you code and use them with time. Like there would be a few things which would become more familiar to you and all when you actually code up and try to play with it. So we have assigned you problems and all. Just try to code them up and play with them. Initially, it would definitely be a bit hectic and you won't get all of them, maybe even any of them. But as and all you try to code more and more, things will become much more familiar. So just try to be with me initially and just try to do out the problems. Try to play with C++ as much as you can. Only practice makes a person perfect. So just try to do more and more practice. And again, I completely agree that the initial part would be a bit difficult and hectic, but in everything in life, initially it would be a bit difficult. Only with time, things become much more comfortable and you get the momentum. Okay, Prasid, what's the query you have?
How the mark 50, mark 5 above in front of the integer is different from the assigning below?
Yeah, okay, that's a nice question and I would have addressed that. So you're saying what's the difference between this and this?
Yes.
Okay, yeah, thank you, Prasid. That's a really nice question. So there is a big difference in both of them. This is the declaration of the array. This is like declaring that, okay, this array exists. And this is assigning it a value or using it. So this is like you are defining to the computer that, okay, my array exists. And this is you're assigning it the value. It looks the same if you see just this thing, like mark 5, but before this particular mark 5, we have this data type integer. So here we don't have. See, at now it would get compiled. It won't show you an error. But if you write int mark 5, it won't get compiled. It would give you an error that, okay, it's a redeclaration. The data type is the difference in both of them. Is it clear, Prashant?
Yes, yes.
Okay, thank you, Prashant. Vineet, what's the question you have?
Yeah, so when we define the array of size 100 and define the values of only 50 variables, so why weren't the values of the rest 0? Like, is it the way C++ was written? Just an empty array, but not filling everything with 0 as soon as we define it.
Okay. The computer, as I said, it just allocates you some memory. So suppose you have defined an array of size 100. You ask him an array of 500. It would give you all the 100 variables, and it would have, like, initially the array would have some random value. It may be 0, it may not be 0. It would be any random value, and because that's not something C++ is concerned with, you have just told him to give give space for 100 variables. So it would have, they would have some random values. After that, whatever variables I give the value, they would get that particular value.
Yeah, but we weren't getting random values for the remaining 50 variables, right? It's simply blank.
No, we did not printed them in the first place. We printed only the first 50 values. I was 1 to 50, not 100.
Oh, was it? Okay, sorry, I got confused.
Okay, yeah, okay. I will just show you that. Yeah, thank you, Vineet. I will just show you that here. So just complete the size part. What's the size is? So again, as I told you, mark 50 would give you 5 variables which are starting from 0. So mark 0 is the first value you can get. So this particular value is mark 0, like index is 0. This is 1, this is 2, this is 3, this is 4. So these are the only values the computer has allocated you. So using mark 5 is illegal because this value is not allocated to you. So if you use mark 5, not all the compilers give you error. This is something that should be given error, but it's not something that like they explicitly do. I'm not very sure why that's not done, but yeah, it won't give you an error then and there. But what would happen is this particular place would have a random value, and it can give you an error in future. So for now, just believe that it's illegal. The computer may not give you an error explicitly, which is sometimes reason for a lot of wrong codes and wrong output. So just remember, if you declare an array of size 5, the values you will get is mark 0, 1, 2, 3, 4. I guess let's not go into the details of why exactly it's like that, but just remember it for now. Just memorize it. If you declare an array of size 5, you will get values 0, 1, 2, 3, 4. Like these are the variables that computer gives you. If you are using anything apart from that, something like mark -1 or mark 5 or mark 100, these are all illegal and you can't use them. So just remember that for now that these are illegal. It's a bit weird that why C++ explicitly doesn't give you an error at that particular time itself. Like there is a reason, but I'm not going into it. But yeah, like just remember that if you declare an array of size 5 or say 100, you'd get 100 values starting from 0. Let me ask you a question. Suppose I declare an array of size 100. I can use mark 0, mark 1, mark 2, mark 3, mark 4. What is the last value that I can use? Like there are a lot of values that I can use in between. What's the last value I can use? Okay. Okay, yeah, you can write in chat, maybe I guess it's fine. Okay, so yeah, that's correct. 99 is the last value. I hope you got it, why it, like how you can figure out. So whatever is the size, that size minus 1 is the last value that you can use. So you can use from mark 0 to mark 99. And you can see these would indeed be 100 variables. So C++ is maintaining its promise that you told him to give 100 values and it indeed gave you 100 variables to access. Just that the indexing of the 100 variables starts from 0. Okay, so if you use anything apart from these 100 variables with the name mark, then those are illegal. I hope that part is clear. Let me go a bit ahead, then I would take up more questions that you have. Okay, so let's see another thing. Let me define it 5 and let me print out the values. So as you all know, the array indexing would start from 0 and it will go till 4. And I will do I plus. Again, this thing is a bit confusing. I completely agree, but this is how C++ it. And there's a reason as well, but not something we'll be able to discuss right now. So just remember for now, if you declare an array of size 5, you get the variables from name 0 to 4. 0 to 4. If you declare of size 10, you will get from 0 to 9. For 100, you will get 0 to 99. Since we have used 5, we will get from 0 to 4. Let me print out the values without declaring them. Let's see what it comes. Let's try this out. So again, when you don't have computer has just allocated you some 5 variables inside it, like some storage for 5 variables, and initially they would have random values. So a lot of times they would be 0, but they are not 0 always. So let's see for our case what these values are. Okay, as you can see, 2 of them are 0, but the other 3 are some random values, not something we even know of what it is. So I hope you got that why I was saying these will be random values. And yeah, so this is the reason why it is like that. So we have 874 and this big number. Let me try 100 values. Oh, okay, shit. Okay, so these are again, the computer indeed printed it, but those are illegal. So let me try define mark till 100 and use the values till 99. So I defined the size 100 and use from 0 to 99, and let me try printing them now. Okay, so these are the values. You can see it's 0 alternatingly or something and random values. Again, these would be completely random values and not something we can trust on. So it's important that you define the values yourself, as in like a variable. Even for a variable, if you won't define a value, it would get some random value. I hope you all would be familiar with that thing. Okay, so so let me give you another way you can allocate values to the array. So what we can do is okay, let me not go into it. Like there's another way you can give values to the array, which is like this. If you give okay, yeah, okay, I will do it up maybe. So if you define an array like this, 13652. Yeah. There is another way you can declare an array and allocate values. So the value of mark 0 would be 1, mark 1 would be 2, 3, mark 2 would be 6, mark 3 would be 5, and mark 4 would be 2. So let's just try it out. So again, this is nothing but the syntax of how you can declare an array and give it a value. Okay. Even from the chat would like to answer what the output for this code would be. It's a bit trickier question, so just think. You can either raise your hand or write in chat. I will show you the code. This is the code. This is declaring the array, and these are 5 values, and these are given to the 5 variables in that order. I'm asking you what will be the output for this code. Okay, there are some answers. 3652. Okay, there are lots of answers, but yeah. Okay, there was Arvind said 13652, which is incorrect. There are people who said 1 and they were starting to ask something, which is again wrong. I guess the first correct answer was from Anurag. So yeah, Anurag, you are correct, and the answer would be these 4 values. I will just show the output, and yeah, so this is the correct output 3652. And why is it like that? Because I told you the values are in this order. So mark 0, mark 1, mark 2, mark 3, mark 4. These are the 5 values that we have. And so mark 0 was 1, mark 1 was 3, this was 2, 3, and 4. So these are these particular values in that order. And since we had printed from 1 to 4, it would print the values of variable mark 1, 2, 3, 4. So 3652 was the correct output. I hope you guys got it. This is again just a way of declaring the, like initializing the values of the array. Nothing else. I hope that part is clear. Does anyone have any queries so far? Either write in chat or raise your hand. Any queries you have, just yeah, okay. Any queries you have, just feel free to write in chat or unmute yourself. Again, don't let a query remain with you. Okay, let's go ahead if you don't have any queries. So again, we saw this way of defining the values of the elements of the array. We already have seen this way of giving values to the array, that define the array, then give values to the elements explicitly. This is 1, 2, 3, 4, and 3 and 4. So this is how we give values, like how we give to variables. And we can also take the values from user. So suppose I have a class of 5 students and I want to feed their roll number, feed their marks to the computer. Suppose my class has five students whose roll number starts from 1 to 5. So what I would do is I would just initialize the array of size 6 so that I can use 0, 1, 2, 3, 4, 5. These are the 6 values I can use. But since I need only roll number 1 to 5, I would just use this part. So just I won't use the roll number 0 thing explicitly. I hope that part is clear. So let me take an input. This is I am taking the input and let me print the sum of it. So I would define the sum as 0. Okay, let me print it first and then do the remaining things later on. Yeah. So this is taking input from the user and this is outputting them for roll numbers 1 to 5. Let me give some marks to the students. See, the first student got 90 marks, second one got 92, third one got 87, fourth one got 99, fifth one got -10. So these are the marks that I fed as an input to the computer, and this is the output it gave, which is right now the exact same thing. I hope that part is clear. This is how you can take the input from the user, which is again how you would do for variables. So I hope that part is clear. And yeah, so like this way you can store marks of a lot of students and play with them, like do a lot of things. Suppose in this case, instead of outputting their values, which is pretty obvious to me, I can define a variable sum and add them up. So what I would do is sum is equals to sum plus mark I, or maybe it's just sum plus equals to this. So what this thing would do is this would add the value of mark I into sum. Sum plus equals to what it would do is it would take the value of mark I and add it to sum. And in the end, I would just print up the value of sum. Let's try it out. 90, 92, 87. Oops, sorry. I would just, yeah. 90, 92, 87, 99, minus 10. These are the values. This is the sum. I will just copy it. This is the sum. I can print out the average as well, which would be sum divided by 5. This is the sum and this is the average. Again, it's not in decimal. Like 358 by 5 would be 71.6, I guess. But the decimal part is not printed because sum was an integer. So only the integral part would be printed. Okay, so that's how you can initialize the values, take their sum, find average, find mode, find median, and you can do a lot of other things as well. So yeah, okay. Yeah, like, do you guys have any questions on what we have done so far? How to reduce the time it took more than 60 seconds? Yeah, like Anurag, yeah, that's the time you gave for writing and not the input is also considered in it. Otherwise, it would have been a bit less. Okay, any other questions so far what we have learned in arrays? I hope the explanation of like the usage of arrays is clear to all of you. Okay. Now there's another thing that we can do. Suppose I need to find the maximum marks that have been scored. So what I can do is, suppose I want the maximum marks to be stored in this variable called max marks. Let me initialize the value as minus 100 because I know minus 100 is the lowest marks that can be scored in the test. Then what I will do is I will just go over the array, and what I would do is if marks of I, if the mark of current student is greater than max marks, if the marks of the current student is greater than max marks, then max marks will be equal to mark I. So we start with max marks as minus 100. We go over all the values in the array. If a particular value is greater than the current maximum marks, then we just update the max marks. And in the end, we would print max marks. Suppose we give it, so this is the code, you give the marks, you find the maximum marks and you print it. So this is a simple code to find the maximum marks in a class. Okay, suppose I gave it as an input 90, 92, 87, minus 10, 99. Would anyone of you tell what the output would be for this code? This is my code. These are the 5 values and my code would print the maximum marks. Yeah, Arvind, you can do that and that would be a more correct way. Okay, no one, like, what would be the output for this code? These are the 5 values. This is my code. It takes the input as all the marks and then find the maximum marks among them and then print it. So this code would print the maximum marks. Okay, there are a few answers and I guess, yeah, indeed both of them are correct. So let me just try compiling it. So here are the 5 marks that we had in our class and our code indeed printed the maximum marks. Let me try out minimum marks with 100, and then if the current marks are less than min marks, then min marks equals to. I hope this part is simple, like it's basic logic. And I would have to give the input again. Okay, 90, 92, 87, 876, minus 10 and 100. Okay, and the output was minus 10, which is the minimum mark score. Okay. Oh, these are the basic things that you can do if you have array. So now you can see you can store a lot of data using array and then just play with them. If you want to find maximum, minimum, average, and a lot of things that can be done with arrays. So arrays are like the basic data structures to store a lot of data. It's like a really core data structures to store the data. In fact, our computers store almost everything as an array. Like our memory array is nothing but how the memory is inside our computer. That is something you would understand later on. For now, just yeah, like you would have gotten the importance of arrays and how to use them. Does anyone have any queries in respect to what an array is or how to use them? Okay. Let's quickly go to the last topic for today, which is time complexity. Okay, this is something you can skip for now. Yeah. So let's go with what is called time complexity. So like again, there are a lot of things that we have learned so far. We started with learning about variables. We learned about how to use variables. What are the basic arithmetic operations in C++? How does a, okay, just a second. Yeah. Yeah, so yeah, we started with learning about basics of programming. Then we learned about variables, how to use variables, what are the arithmetic operations we can do using variables. We learned about if else, how to use if else, how can we write basic codes using if else and all that. And we also learned about loops, how to use loops and all that. Today, we learned about arrays and how to use arrays. What are the various things that we can do using arrays? So I hope this like these three things basically variables, conditional statements, and loops and arrays. Like these are like more or less everything very like the basic of all the modern programming languages. You can do almost everything using just these three things. Even the other things that are being available in C++ can be implemented just using these three things. So that's why this forms the core. From now on, whatever things we would learn in future would be things that are derived from these things. These things were more or less independent and not like we were not using exactly one thing for the other. Like we did use for loop to print the values of the array, but not in declaring the array. From now on, like in future, the things we would learn would more or less be derived from these things, or we would use them to solve them and all. So these form the core of C++ and our learnings in future. So I request you all to get a strong grip in all of it, all of these, solve out the problem sets that are there, and that would make you more familiar. Again, I told in the start that just starting up in programming is a bit difficult and you would have the fear. But if you just try to play with the language yourself and solve more and more problems, things would become much more clear over time. So yeah. So yeah, that's the basic of programming. Now, the last topic for today that we would be learning would be time complexity. So we have learned all of this, but when to use what or how exactly we can use them is something we would study in this topic, time complexity. Like it would give you an idea of when to use what and when that can be used or not. So again, we said computer in the first class for G0, we had said computers are nothing but dumb humans with a lot of computational powers. So you can consider them as pretty dumb humans with like no brain of themselves, but a lot of computational power. So we say that they have a lot of computational power, but even computers' computation power is not infinite. It is limited and it has some limitations of its own. Just that those limitations are much more beyond what we as humans can do in our brain. But they have limitations, and that limitation is what like gives the job to us as programmers to write codes that can do our task in sufficient amount of time. So if you give any task to a computer, it would take very less time as compared to a human, but still it would be a finite time. It cannot do anything in infinite time, like in zero time. It would take up a finite time, and which is where our role comes in to ensure that the task that we want to do can be done in, say, our time limit. Like suppose we want to get it in 1 second, 10 second, or 100 second, then it can be done. So there are lots of things that a computer can do in 1 second or something. Suppose you're given a task, a good programmer may write a code that would do it in, say, 1 second or 5 seconds. But at the same time, there could be another code written by another person, which would indeed take 100 years even for the fastest computer available to us. 100 years, like you would be able to calculate that as well, that how much time a code will take given a particular data and all that. So that is where time complexity is important, because it will give us an idea of how much time a particular code will take. That's the importance of time complexity. So let me go into and explain you how you can find time complexity and what is time complexity. So again, time complexity is a measure of the number of elementary operations performed by an algorithm. So again, two codes can be considered as two algorithms because they would do a particular task to achieve a final result. So again, you can call them algorithms, and time complexity is a measure of the number of elementary operations performed by an algorithm to complete a particular task. What are elementary operations? So in a code like this, taking one input is an elementary operation. Defining a variable is one operation. Defining a variable is one operation. One if statement is one elementary operation. Assigning again is one elementary operation. Adding is one elementary operation. Subtracting, multiplication, arithmetic, and all of them are one elementary operation. More or less what you can say is anything apart from for loop and all, anything that is written in one line, or like you can write all the things in one line, but anything, any particular step is a elementary operation. So if you see this particular code in terms of a computer, suppose you were the computer yourself, then what you would have done is you were processing the code, you came to this line, you defined, say, 6 variables to your user, then you came to this line, you saw that, okay, I have to do this thing 5 times. This mad guy wants me to do this thing 5 times. So what you did is you started a variable from 1 to 5 and you took input, the first value the user gave in this one line, in this particular variable, mark 1. Then you saw that you have to again do it. So you again came here and took the second input. Then you again came here, third, fourth. You came here 4th time and 5th time. Every time you are doing one step, which is called one elementary operation. So one step of a computer or one line is called one elementary operation. It's not something which is very rigidly defined, but I hope you all would get it. So again, more or less, you can think anything apart from loops is one elementary operation, like that particular line. If I write, if I declare 5 variables, then these are 5 elementary operations. 5 variables been declared, and these are 5 elementary operations. So this is how you define an elementary operation to be. It's not a very clear definition, but I hope you would get some intuition about it. And yeah, like now time complexity is the measure of the number of elementary operations. Basically, how many elementary operations would be performed by your code? How many elementary operations would be performed by your code? And like initially it might think like a bit weird idea how you can exactly find the each like number of elementary operations, but one main idea is that, the main idea is that a particular elementary operation, something like this, would take around a nanosecond or something for computer to do. But so we don't exactly need an accurate amount of, like, say 572 elementary operations were performed. That's not something we're interested in it. We're interested in roughly the number of elementary operations that the computer did. So something like 10 raised to 6 elementary operations and 10 raised to 10 elementary operations. 10 raised to 6 and 10 raised to 8. These are considerably different, as we can see. So these are something we need to compare. Suppose we have two algorithms. We know that one algorithm would do 10 raised to 6, which is like 1 million operation, while the other one would do 1000 trillion operation. So we can know that definitely the first one is much efficient than the second one. And that is what we want to compare. So as time complexity, we would compare the number of elementary operations that our code will perform. So let's go more into it and like see a few examples that would make the things more clear for us. Okay, and again, for a particular code, like the time complexity also depends on the data that is provided. It may happen, like suppose I take a variable, and what I say is if let me remove this part of the code. Suppose if I say if x is greater than 0, then print the values from 1 to 100. I will use a for loop and print the values from 1 to 100. If x is less than 0, then just print 100. Then just print x. So you take a variable as an input. If it's greater than 0, you print the first 100 integers. If it's less than 0, then you just print its value. So for some codes, your actual elementary operations that your code will perform can also depend on the input that you give. That's why we have two things, which is worst case scenario time complexity, which is like what is the worst case, or like in worst case, how many elementary operations your code will perform. And there is something called average case time complexity, which means on an average, how much time complexity or how many operations your code would perform. So we will not go into average a lot. For now, what we're interested in is worst case time complexity. So in worst case, how many elementary operations your code would perform. So for this particular scenario, we can say that in worst case, it will perform 100 elementary operations. So maybe say 100 for this, one elementary operations for this comparison, and say 2 elementary operations for defining the variable and taking as an input. So you can say in the worst case, our code will perform 103 elementary operations. Is that part clear? Do you guys have any queries in this particular code at least? Like, do you guys agree this code would perform 103 elementary operations in the worst case? In the best case, it may perform one. Okay, let me ask that to you. Okay, first of all, do you guys have any queries in the number of elementary operations this particular code would perform? If you guys have any queries, you can raise your hand or write in chat. Okay, yeah, I was about to ask, what is the number of elementary operations this particular code would perform in best case? Can you repeat how you counted the number of elementary operations? Okay, Raghav, I will just repeat it. So I have to find the number of elementary operations this code will perform in the worst case. I can clearly see that the worst case would be when it goes inside this loop, because this loop performs more operations. So defining the variable would take one elementary operations, taking input would take another elementary operations. This comparison, this if loop comparison, like if x is greater than 0 or not, this is another elementary operation. And this particular loop would do 100 elementary operations. So that way it takes 103. Yeah. And like if you are a bit smart, you can actually see that the worst case is even more, because we are defining this particular integer in the first place. Like we are defining int I is equals to 1. So this would be another elementary operation. We are incrementing I by 1 every time. That's also another elementary operation. And we are also comparing I less than equal to 100 every time. So it would be another elementary operation, but we are not going into it. We just want an idea of elementary operation. Okay, yeah. So this would be around 100 for this and say 2, 3 for this. So this would be around 103, worst case number of elementary operations. And in the best case, it would be 2, 3 and 4. So in the worst case, you would perform 4 elementary operations. One for defining int, then second for this, third for this comparison. And since this comparison is false, it would go here and it would print this. So there would be 4 elementary operations in the best case. Yeah, Arvind, you are correct. Yeah. So I hope the number of elementary operation is fine. It is not very precise. It's a bit intuitive. It will get more formalized in the next few slides. Do you have any questions for now? Okay, yeah, Akhilesh, go ahead.
In the if-else loop, like if-else state,
Okay, yeah.
even the else state is considered an
Okay.
elementary operation.
You can see that the computer does not had to do any computation or any work for that. It just did this comparison, and since it was false, it directly went on to here. So there is no comparison or some work that computer has to do here. You can count it like one elementary operation doesn't make much difference because it takes pretty less time. I've already missed like 100 or 200 elementary operations here, but it's fine. But yeah, like just to answer it, like else you can consider it or not consider it, doesn't make much difference. I think it is not correct to consider it because like the comparison was done here, after which you directly went on to here.
Okay, got it.
Okay, thank you, Akhilesh. That was a nice question. Does anyone else have any other question? It can be any question, guys. Please feel free. I'm saying feel free, but yeah, I know there is time limitation as well. Okay, yeah, Juvant, you can ask your question. Let me give you mic access. Yeah, Juvant, can you try muting yourself?
Yeah, can you hear me?
Yes, Juvant. Jaswant, sorry. Yeah, Jaswant, I can hear you.
Is defining an array considered as a single elementary operation, or it is as many as a number of variables that we define?
Really, really nice question, and I wanted some of you to point it out. So thank you, Jashwant. I would answer it. So basically, defining an array, what a computer does is it just reserves this particular memory. So it just marks, say, a flag over here and over here that this value is allocated to Jashwant and I don't have to use it. So even it's of size 500 or 1 million, it will just mark 2 flags over here and here and do nothing else. So you can consider that it's like 2 elementary operations or 3-4 elementary operations, but it's like a constant. It is not dependent on the size of the array because it's not doing anything with the values. If you define the values in that way, like array 5 and give it values, suppose you do something like mark 5 and give it values 1, 2, 3, 4, 5. If you do this, then this would take time 5 because you give 5 values. But if you just allocate them, like if you just define them that, okay, these are 5 values, then it won't take 5 time or 100 or 1000 time. It will just take constant time, 2 or 3 elementary operations. Is it clear, Jashwant?
Yes, brother, I got it.
Okay, yeah, thank you, Jashwant, for asking a nice question. Anyone else have any question related to the number of elementary operations or anything? Okay, let's go ahead with learning time complexity. So yeah, what is worst case scenario time complexity? This is an upper bound to the number of elementary operations our code would perform. So there is a term to give which we have given to this particular time complexity. It is called big O notation. It is a mathematical notation used to express the worst case time complexity of a particular code with respect to the size of the input. Okay, let me tell you how time complexity can depend on the size. So suppose I give a simple code. I write this and I want to find the sum of first n values, first n variables. So what I would do is declare an array, declare a for loop from size 1 to n. Define a for loop to go from 1 to n, and then sum plus equals to I. So this would add the value I to the sum, and in the end I would print sum. So let me try it out. For 5, I think the answer should be 15, and indeed we got 15. For 100, the answer should be 5015, and it is 5015. So it's a simple code. What it will do is it will take a value n and it would print its sum. Print the sum of first n values. So this is one case in which the output is dependent on the input, and thus in terms of n, we can say that this particular code will do n operations, or maybe you can say it would add n times. So these are n operations. It would do one operation here, one operation here, one operation here, and say one operation here. There would be a few operations here as well, but I'm missing them for now. So there would be n plus 4 operations that this code will do, n plus 4 elementary operations that this code would do. And now you can see that it's not a constant number of operations. It depends on the code itself. So whenever we have a complexity that depends on the code, we use whenever we have complexity dependent on the input, we use this notation called big O notation. So for instance, this code will do n elementary operations, or n plus 4. Again, 4 is a constant, so we at times ignore constant because they won't take much time. Since it would do n operations to go through the array, which was like this particular code, or this particular code, which would find the sum of first n numbers, the time complexity for this particular code in big O notation, which is like worst case complexity, is called O of n. I hope that part is clear. So the time complexity for this particular code is big O of n. And yeah, so cause this will do n elementary operations. Suppose there was some code which say did 2n elementary operation. You can say as time complexity to be big O of 2n. Suppose I just repeat this for loop, then you can say it to be big O of 2n. Suppose instead of repeating this, I did something like go from n to n square. So now the time complexity for this particular code would be big O of n square, cause this will do n square elementary operations. I will start from 1 and go till I less than equal to n square. So the time complexity for this code then would have been big O of n square. I hope it makes sense. Do you guys have any questions with respect to this? Okay, so let me try out a few examples. So this is the code. You take n, you define sum to be 0, and you do this. What is the time complexity of this code? Write in chat or speak up. What is the time complexity of this code in big O notation? Oh, no one. Okay, there are few answers. I would still give you guys a minute or so to think. Okay, yeah. Okay, we have a few answers. Okay, yeah. Anurag says O of n. Sudhir says 3n. Kunal says n. Big O of n. O of n. Yeah. Okay, so all of these are correct. You can say its complexity to be 3n or n plus 4, n plus 5. In big O notation, we kind of ignore the constants. So we would always say the part that depends on n, which kind of plays the crucial role. So if you have to say a particular, like a one number, then it would be like the time complexity would be big O of n. So this would be the time complexity for that particular code. There's another way using which we can find out the time complexity of a code. What we can do is initialize count as a variable to count the values or the number of operations, and increment count every time we do an operation. And in the end, we can just print the value of count. Okay, let me change this. Yeah, so if I give the value as say 100, I got the output and this was count. Let me make it clear. Count is equals to this. Okay, if you give 100, count is indeed 100, which indicates you did 100 elementary operations. Like there are a bit more than that, something like 305 or something like, but we will ignore the constant part for now. Like constant in multiplication or addition, because it won't take much difference later on. So yeah, so we did 100 elementary operations here, which is like a pretty straightforward here, but for the further examples, you would have a bit of difficulty. Let's see if you can do. So what would be the time complexity for this code? You can have a look at it. It starts from I1 to n. Then you have j, which starts from 1 and goes to I. And you check if I is divisible by j. If I is divisible by j, you print it. Okay, let me code it up for you guys. Okay, first of all, would anyone like to tell what this code would do? Okay, this is my code. I hope the code is clear to you all. Okay. Yeah. Would anyone like to speak up what this code will do? Let's start with that first. Okay, just give me a second. You can think on it. Okay, yeah, you can raise your hands if you got how the code will go. Yeah. Okay, we have one hand raised. Is that like the only one who got what this code will do? We have two hand raised, 3, 4. Okay, you can see the code. I guess it's not that difficult to see. I will just explain okay what the code is doing. It runs a for loop with I going from 1 to n. Then another for loop where j will go from 1 to I. And in each of the iteration, you would see if I modulo j is 0, which is if j divides I. If it divides, you would print j. Else you won't do anything, and then you just complete that. But there are a few hand raised now. Let me ask, say the first guy, Satyankar Gule. Can you
Yeah.
Yes, Satyankar, I can hear you.
Yeah.
So what
So
this code would do?
it would print the factors of all the numbers from 1 to n.
Okay, let me just do it. Suppose I write 10, what would be the output?
It would print 1 in the first line, then 1, 2 in the second line, and 1, 3 in the third line, and 1, 2, 4.
Okay, yeah, I get it. Let's see. Okay, so you are indeed correct, Satyankar. Thank you. The output is 1, 1, 2, 1, 3, 1, 2, 4, 1, 5, 1, 2, 3, 6, 1, 7, 1, 2, 4, 8, and so on. So this is like the number of like the factors for each number. The divisors of each number were printed as said by Satyankar. And that was what the code would do. Let's talk about its time complexity. So what would be the time complexity for this code? Satyankar, would you like to answer?
I think it would be, I mean, 1 into 1 plus, I mean, technically the number of factors into.
See, we are printing this thing only for the factors. Actually, we are doing the print thing only for the factors, but we are doing the comparison or the operation every time.
Okay.
So you can consider that this particular thing is one operation altogether. Like I know there would be some constant additions because of this, but just ignore that for now and focus on just this. Like consider this complete thing to be one elementary operations, which is performed every time, irrespective of whether the number is a divisor or not. Can you tell me the value of count in the end? Satyankar.
Would it be like 1 square plus 2 square plus 3 square and so on?
That's not exactly correct. Let me ask someone else. You can think on a bit again. Sudhir, would you like to answer? What will be the value of count? Sudhir. Oh, okay. I'm not sure if you were able to speak. Okay, there are a few answers already in chat, so maybe I will take it up from there. So yeah, the answer is indeed correct. The value of count would be n plus 1 by 2. Suppose if I write 10, then the output would be 10 into 11 by 2, which is 55. And the count is 55 because for in the first time when I is 1, you would do one operation. Then for I equal to 2, you would do 2 operation. Then 3, you would do 3 operations. So the time complexity for this particular part of code is big O of I. Like it would do I operations. So 1, 2, 3 up till n, and the summation would be n plus 1 by 2. So those would be the number of operations. So the number of elementary operations this code would perform would be n plus 1 by 2. I guess there is someone who has written a bit more accurate, but the code, like the main thing in the end is what would be the time complexity in big O notation. So what would be the time complexity in big O notation? You can write in chat, I guess. Like what is the mean power of n that would dictate the number of elementary operations? Okay. There is few answers from Haricharan and Sudhir, which are both correct. The time complexity for this code is big O of n square, which I hope all of you would agree, since the number of elementary operations were n plus 1 by 2, which you can see that there is a factor of n square and a factor of n, and among them n square would be dominating. So the time complexity in big O notation would be big O of n square. This does not mean that there would be n square, exactly n square elementary operations. It would be on the order of it. It's basically to indicate how the number of elementary operations would grow when we increase n. And that thing can be denoted with just saying it's n square. I hope that idea is clear. Definitely if a code is there which take 5n square and a code is there which takes n square by 2, then the n square by 2 particular code would be more efficient. But more or less, if like we're given say a code which takes 5n square and another code which takes n raised to 4, then we can clearly say that n square 1 is better. So that's why we only deal in the powers, because it gives a more accurate, or like not accurate exactly, but it gives you a good idea of comparing two codes. So that way you can compare two codes. So the big O complexity, time complexity for this code is big O of n square. Worst case time complexity is big O of n square. Let's go on to the next example, which would be a bit more trickier. Let me just. Okay, so there are a few codes. Let's have this one for the last. We would see the later up, like we will give you the later on ones as a homework. This is the last code for today. Let me just code it up.
But I have a doubt, like, can't we directly say that if there are 2 loops running, the bigger complexity will be n square, and if there are 3 loops running, it will be n cube.
Okay, you can say that, but just wait for this example. This would give you a more idea. Like you can say that if they are linear kind of thing, and like it could be there that the outer for loop runs for n times, but the inner for loop runs only for the 5 times. Then it may not be n square, right? So just take a next example, and this would be a nice counter example to your thinking. So yeah. First of all, what this code will do. Anyone, like, please raise your hand. Okay, Akhilesh has raised hand. Anyone else from the chat or from the meet who would like to suggest what this particular code would do? We have I going from 1 to n, and then we have j going from I to n and incrementing by I every time. Just note this. Okay, no one. Nice. I thought this was easier. Like this was easy, like at least to think what the code would do. Okay, we have one hand raised. Nice. We have two. Okay, one. I guess this is a bit confused. Okay, we have a few more hand raised. Let me give you guys 1 more minute to think. I hope like there would be more people who would at least know what this code would do. Like it is not much, right? Like there is no comparison and all as well. There are just 2 for loops and 1 output statement. This should be easy, guys. Come on. Okay, there are a few more people, but still I expected a bit more. Okay, it's fine. Yeah, and Tony Roshan, can you try to unmute yourself?
Hello, can you hear me?
Yeah. Yeah. Hello, Anthony. Would you like to suggest what this code would do?
It's printing the first n multiples of the number, starting from 1 to n.
So first n multiples of all the numbers.
Yeah.
So suppose I give n equal to 5, what would be the output?
So it will print it will start with the first 5 multiples of 1, then the first 5 multiples of 2, and so on.
So 1, 2, 3, 4, 5, 2, 4, 6, 8, 10, 3, 6, 9, 12, 15, and so on.
Yep.
Okay. Okay. I don't exactly agree with Anthony. Is there anyone who would like to correct him? Okay, let me go on to the next person. Sudhir, what do you think would be the output? Okay, I guess Sudhir wasn't able to unmute. Let me go on to the next person. Yeah, Sudhir, I'm sorry, I don't know what exactly the issue. Haricharan, since Haricharan has not spoke so far. Yeah.
Can you hear me? Hello?
Yeah, Haricharan, I can hear you. What do you think?
it will give you math tables, right? Like for example, 1 table and 2 table up to n, like not n times, but but the last number would be n.
Code if n is 5.
Okay, so if n is 5, you would have 1, 2, 3, 4, 5, and in the next line you have 2 and 4, and the next line you have 3, and the next line you have 4, and in the next line you have 5.
Okay, I guess that should be correct. Let's try to see it. So I give n is 5, and indeed what Haricharan said happened. We got 1, 2, 3, 4, 5, 2, 4, 3, 4, 5. Yeah, thank you, Haricharan, and that was correct. And you can see, I guess, why that happened, because the value of j starts from I, and you increment it by I every time. So that's the output of the code, and that you can see what the code does. Let me give you another example of say writing 10. Then you got 1 to 10, then 2, 4, 6, 8, 10, then 3, 6, 9, and so on. So yeah, so thank you, Richaran, that was correct. Let me ask you guys a sub question now. What do you think is the time complexity for this particular, okay, what is the time complexity for the complete code? Let me ask you the main question directly. So what is the time complexity of this code? You can think on it. It's not that straightforward. Okay, I would ask you to write it in chat. Just write in chat. What do you think is the time complexity for this code? Okay, we are getting few answers. We have 1 answer, 2 answer. Nice. Okay, let me give it out. So O of n is the wrong answer. You can think on it now. I doubt if anyone in the meet can give the correct answer. Okay, yeah, sure. It's a challenge to you all. Can you find the correct time complexity for this code?
Like it's something like n log n.
Okay, who is that?
Haricharan.
Okay. Okay, let me give others some time to think, and I would tell if that's correct or not.
Yeah, okay.
Okay, you can write in chat whatever you think is the correct answer. This is the code. There are some answers. Okay, so let me tell you what the correct time complexity would be. Can anyone of you tell what's the time complexity for this particular part of code? Just this part of code. Given a particular value of I, what is the time complexity of this part? Just write in chat. What is the time complexity for this part of code? Like how many operations will be done in this part of code given a particular value of I? Okay, yeah. Yeah, Akhilesh is correct, and I guess some of you would also be knowing. So what you can see is in this part, J starts from I, we increment in steps of I, and we go on till n. So I, 2i, 3i up to n, and you can just write it down and you would see the number of operations this particular part of code would perform would be n divided by I floor. You may ignore it for now. The time complexity, like the number of operations this particular code would perform would be n by I. So say if I was 2, then we got 2, 4, 6, 8, 10, which were like 5 values. So the number of operations this particular code would perform would be n by I. And now what we need is n summation for all i's, which would be n by 1 plus n by 2 plus n by 3 plus n by 4 up to n by n. And let me just. Okay. So yeah, our time complexity would be n by 1 plus n by 2 plus n by 3 up to n by n. So summation over all this would be our time complexity. What we can simply see is we can take out n. So we take out n as common, which gives us 1 by 1 plus 1 by 2 plus 1 by 3 up to 1 by n. And now this summation, you can, if you plot it on graph, like there is basically a thing to find a summation of a big sequence, which is to equate it to its integration. Like for now, what you can see, like what you can keep in mind is if there is such a sequence and you need to find its summation, you can approximately equate it to its integration. And like this is like a known fact in max that sum of this harmonic series is log n. To give you an idea of where it comes off is from, you can imagine this sequence to be like a function 1 by x, where x goes from 1 to n, right? And summation is roughly equal to integration because of something, like there is a particular proof of it, but just not go into it. But yeah, this summation is like summating 1 by x, which is roughly equal to its integration. And integration of 1 by x, I hope you all would be knowing, is ln x. So, and since x goes from 1 to n, if you put the values, you would get as log of n minus log of 1, which is log of n. So this particular summation is indeed log n. And what Haricharan said was correct, that the time complexity for the given code is n log n. So the time complexity is big O of n log n. Does anyone of you have any queries in this particular code? Yeah, like n tends to infinity. Okay. Okay, let me just raise down all hands. Yeah, do you guys have any queries in this particular code and its time complexity? If you guys have any queries, feel free to raise your hand or write in chat. Okay, Abhishek. I'm not sure how else to pronounce your name. Yeah, Abhishek, you can unmute yourself. Okay, if you aren't able to unmute yourself, Abhishek, you can write your query in chat as well. It's completely fine. Okay. Log to the base. Okay, yeah. So, okay, that's a nice question. Like this summation thing would give you log to the base e, like integration of 1 by x is ln x. So it would be base e. But even if you change the base to say 2 or something else, it would give a constant multiplication. Like you can do that calculation. It would give a constant, say k in the multiplication. And in bigger notation, we kind of ignore constant. So you can say it to be n log n to the base anything you want, like any constant, 2, 3, 4, 5. For now, like in general, we consider it to be 2 in programming. So if we are saying, we would say it to be 2 because it's kind of a standard in programming. So you can say it's n log n to the base 2. I hope it makes sense. Because like we are anyways ignoring constants for now. We are not going into exactly the constant in the multiplication and addition. Is it clear, Abhishek? Can you write something in chat? Okay, thank you, Abhishek. And I'm sorry if I'm pronouncing your name wrong. Are there any other queries? We have 2 more codes for you to find the time complexity, but we won't go into it exactly. We will share the slides with you, which you can look at to have some fun, and you can write the answers to us. Okay, there is a quiz we have for you guys. You can access it from the chat. I hope you all would be able to access it. Yeah, this is the quiz. I guess you should be able to see like that. I plan to discuss it, but we are already over time, so we won't be discussing the quiz right now. If you have any queries, you can ask it, or else they would end the meet. So are there any queries regarding to what all, everything that we have learned today? Anything from arrays, time complexity, or the last particular code? I guess the last code with time complexity was a bit interesting and fascinating. So the time complexity is a bit different and log n. So yeah. Okay, guys, thank you all. I hope you all enjoyed today's session and you got something to learn. Keep on learning, solve the problem set. We would release it in some time, solve it up, give this quiz as well. If you get any quiz at any time, feel free to ask it on to us in the group, or you can DM to any of the admins. If you have any queries right now, you can stay or else you can leave. Thank you all. Bye-bye. Yeah, thank you, Lalit. Thank you, Koneru, Nashib, Nitish. Thank you, Sudarshan. Thank you, Sudhir. Thank you all. Thank you, Prashad. Yes, Abhishek, you can ask your question. You can write in chat, I guess. Oh, hard to type. Okay. Abhishek, you can try unmuting yourself. I've given you the access. Or maybe you can get to me in DM, I guess that will also be fine. Like I'm in a bit of hurry right now for something. So yeah. Okay, yeah. Thank you, Abhishek. Thank you all. We would end the meet now. Thank you all for being here.